Hello, welcome to everyone in this video. In this video, I want to discuss about the question which asked in Calcutta University semester 4. This is the part 4. In part 1 to 3 we already discussed about question number 1, then question number 2 and 3. After that we discuss question number 4 and 5. In this video we want to discuss this question number 6 and 7. If you want to watch the previous lecture, you can go through the description box. The playlist link are given there. So let's start first question, which is question number 6a, which state that the two Lagrangian, that is L and L prime, are related by this equation, that is the L prime is equals to L plus df by dt, where f is a function of generalized coordinates, that is f is the function only the function of q, which can be depend on the time t, right? And then from the Hamiltonian principle of least action, so the both the Lagrangian will be give the same equation of motion. That's mean using this Hamiltonian principle, that is the Hamiltonian principle, that is delta S, that is nothing but the delta L dt, least action, principle of least action. This is called principle of least action. Using this relation, we need to show that the equation of motion follow the same equation of motion of this Lagrangian L as well as the L prime. So for that we taking this relation and find out the least action, that is the S prime on the Lagrangian L prime. Put this value L prime in terms of L as like that, and after separating these two function and integrating, we get this point. And from the least action method, we can say this initial point or final point are same. If we take any path but the initial and final point are the same, that's why the integral value of these two are equals to the other, because there is no change at the end point at the fixed point. That's why this delta of these two end point, if this can be taken as q1, this point taken as q1 point, and this point taken as q2 point, okay, as these are fixed, so their variation will be 0. As these two are 0, so delta S prime is equals to delta S. As delta S equals to 0, so we can easily say that delta S prime also 0. So we can say that the L as well as the L prime follow the same equation of motion. I think clear about this answer. Next question says that write down the Lagrangian of an one-dimensional harmonic oscillator. Find out the generalized momentum, hence the Hamiltonian of the harmonic oscillator from this Lagrangian. Then find out the canonical equation of motion, that is the Hamiltonian equation of motion. For that, we need to first find out the kinetic energy of this harmonic oscillator, which is nothing but the half mv square. V is the x dot square, because this is one dimensional. If this is 3 dimension, there is x dot square plus y dot square plus z dot square, but this is one dimensional, that's why we write down only x dot square. So T is equals to half m x dot square. Then potential energy is nothing but 1 by 2 kx square in case of the simple harmonic motion or the harmonic oscillator. So by the definition of Lagrangian of the system is L equals to T minus V. T is the kinetic energy, which is half m x dot square, and V is the potential energy, which is half k x square. So this is the Lagrangian of this system. Now then we need to find out the generalized momentum. Generalized momentum Px is the del x by del x dot. Px is equals to del L by del x dot. X dot is nothing but the velocity, L is the Lagrangian. So if you take partial derivative of this Lagrangian with respect to x dot, we get mx dot. So this is the generalized momentum, that is Px is equals to mx dot. Then we can easily find out the Hamiltonian equation of motion. H is equals to summation pk qk dot minus L. Here only one dimensional, so only px x dots minus L. Put this value of px here, we just find out this relation and change this x dot into px. So this is the H, px square by 2m plus half k x square. So the canonical equation of motion of Hamiltonian can be find out. X dot is nothing but del H by del px. So if you take partial derivative with respect to px, we get px by m, and px dot equals to minus del h by del x, that is the minus k. So this is the Hamilton equation of this motion. Go to the next question. Next question says, so that the under time independent harmonic constraint kinetic energy T of a system of particle will be homogeneous quadratic function of generalized velocity. Hence, so that this, so we need to find out this T is a homogeneous quadratic equation of velocity. So if we take the position vector, that is r, which is function of this generalized coordinate q1, q2 and qn, the corresponding velocity is nothing but the dri by dt. So if you take the partial derivative with respect to different coordinate system, generalized coordinate system, and their corresponding the velocity term, so the kinetic energy is nothing but the half mv square. So their dot product gives you the summation of these two things. So if you take this part, this portion, that is summation of this ri with respect to this one, take as the aji, that is the coefficient of this qi qj. So we can see this satisfy the quadratic function, because there is two summation qj and qk, j summation over j and summation over k. That's why this is the quadratic function. Now we need to prove this relation. For that we find out del t by del qi dot. So if you take this del t by del qi dot, we first derivative with this one, then qi dot is 1 and corresponding this qi dot for that one. So this the same of the summation along the k. So this gives you this one. So this is nothing but the 2 of t, and this is actually the Euler theorem. This is nothing but the Euler theorem, which says that the summation over I equals to 1 to n xi del f del xi is nothing but k of f. K is the degree and f is the homogeneous function. I think clear. Next question. Next question says, a smooth wire has a form of helix. So helix is nothing but like a spring or solenoid. Okay, so their equation of this helical path, you know the DNA have the helical path. So the equation of this helical path is x equal to a cos theta, y equal to a sin theta, z equal to b theta. If you take their derivative, that is x dot equals to minus a sin theta theta dot, y dot equal to a cos theta theta, z dot equal to b theta. Hence the kinetic energy half m x dot square plus y dot square plus z dot square. So they are square adding this thing, you will be obtain this equation. So just rearranging them, the sin square plus cos square theta gives you 1. So this is the kinetic energy, and the corresponding potential energy mgz, z is nothing but the b theta, have the gives the b theta. So the corresponding Lagrangian equals to kinetic energy minus potential energy, that is the t minus v. Put this expression of the t and the corresponding v, so you will be get the expression of the Lagrangian. From this Lagrangian we can find out the generalized momentum. This is the similar process we just do in the previous question. So this is the generalized momentum, that is p theta, here only function of theta. That's why we get only one generalized momentum, that is the p theta is nothing but del L by del theta dot. So if you take this partial derivative of theta dot, you will be get this relation. So this is the generalized momentum. After that we get find out the Hamiltonian. Hamiltonian L H equals to summation of pk qk dot minus L. Here only one variable, that is the theta. That's why this summation over k is learned only one, that is the theta. That's why this is p theta theta dot minus L. Put this value of theta dot from here, you get the theta dot is equals to p theta divided by m bracket a square plus b square. Putting this value, you will be obtain this expression of the h, that is the Hamiltonian. So the Hamiltonian can be written in this form, that is the p theta square by 2 m a square plus b square plus mg b theta. Right. Next question is says that the find the equation of motion. For find out the equation of motion, we need to find out the del L by del theta dot from this expression. This is the expression of L for Lagrangian. From this Lagrangian equation, we find out del L by del theta dot, and the ddt of del L del theta dot is like that, and del L by del theta is like that. So this equation of motion of the Lagrangian equation of motion is ddt of del L by del theta dot minus del L by del theta equals to 0. Putting this value of this expression, that is the ddt of del L del theta dot is m square plus b square theta double dot minus of minus g mg b. So this is the equation of motion of this equation. I think clear about this question. If there is any doubt, you must comment in the comment box. So take care. We'll meet in the next video as soon as possible. Thank you.